Okay, welcome everybody. It's a beautiful, nice weather, nice day. We welcome you all. This is our annual UNIFERT Open Field Day. Together it is today a very, very special day. It is not only the Open Field Day, it is also the Research Day, the FAFS Research Day in Agriculture. This is really a great pleasure and a great honor for us to have this day together with the AUB Research Day. We know that what we are doing here is in fact it's a demo trial. It's a big demo trial, well organized, scientifically replicated, everything. But at the same time, it is a kind of research that everybody can benefit of it. First of all, I would like to welcome you in English. Then I will shift to Arabic since most of our audience is Arab speaking, coming from Arab countries and Lebanese, and everybody would like to listen in Arabic. So I would like first to welcome our Dean, Dr. Rabi Muhtar. Also, all the staff, AUB staff, Dr. Mustafa Haidar, all doctors and professors. And in the name of UNIFERT top management, that is Mr. Peter Herechtakian, who is the president of UNIFERT Group worldwide. He's our top boss. He's our president, all of us. He's here with his lovely wife, Natalie. Welcome, Natalie. Welcome, Peter. And Mr. Josh Fayyad also. He's the general manager for UNIFERT Holding. And Khalil Milki, myself, I'm the general manager for UNIFERT SAL and the head of business development. In the name of UNIFERT top management, I would like to welcome everybody coming from far, especially from the countries which are a bit far from us, that take us one full long day to reach when we are going there for a business review or for a board meeting. I mean, somebody coming from Iran. And I would like to mention here the general manager of Rojin factory. This is the largest tomato processing factory in Iran. You are welcome among us here. And another far place, Kenya, where we have also Mr. Jack Masawa, our sales manager in our Laklan affiliate in Kenya. وأهلا وسهلا كمان بالجميع اللي جايين من الدول المجاورة لنا محل ما في يونيفرت، جايين من سوريا، من الأردن، من مصر، ممثلين من العراق، من الجزائر، من المغرب. أهلا وسهلا بالجميع، بنرحب فيكم ونتمنى إنه هالنهار يكون كتير مفيد وكتير حلو لإلكم. بدي ألفت نظركم لشغلة كتير حلوة، إذا بتطلعوا على يساركم كلكم سوا بتشوفوا هالفيلد الحلو. This is a lovely field. بهالفيلد هيدا بتلاقوا 25 صنف crops، في 25 صنف خضار مزروعين، 25 different vegetable crops. They are all synchronized to mature in the same week. يعني كل هال 25 صنف يلي فيهم 400 variety. بكرر 400 variety مزروعين بهالحقل، 400 varieties. 200 من هالvarieties هن varieties جديدة، new varieties يلي رح يفوتوا على البلد لأول مرة، ورح تنقوا منهم اليوم انتو تعملوا سيلكشن لاصنافكم، ورح نساعدكم نحن حاطين لكم هونيك كل اللي لازم تشوفوه، حاطين الاسامي تبعهم، فيكم تطلعوا، فيكم تدسوا الاصناف، وفيكم تدقوها، وفيكم تصوروها واللي بدكم اياه. فبس لنقلكم انه هيدا الشغل هو شغل حقيقه مهني كتير، very professional work، وبتأمل انه نقدر نستفيد كلنا من هالشغل يلي كلنا سوا عم نعمله. علاقتنا بالايوبي علاقه كتير متينه عمرها بالنسبه لهالموضوع هيدا، موضوع هالترايل هيدي فوق ال 25 سنة. أنا الحقيقة ما كنت عم بعدهم، بس من شي شهر تقريبا كان في البورد اوف تراستيز هون، وأنا كنت معهم كوني عضو بمجلس الإدارة تبع الادفايزري بورد تبع السكول، ودكتور مصطفى كان عم بعد وحط يونيفرت وقال 24 years. ما بعرف إذا كنت حاسب هالسنة، فأنا عم بقول 25. ف 25 years of very close collaboration، كثير قراب من بعض وعم نشتغل ايد بايد لحتى كلنا سوا نقدر اول شيء نفيد الناس يلي عم بيشتغلوا بهالحقل، ومعظمهم من التلاميذ يلي عم بيتخرجوا بالحقل الزراعي مهندسين زراعيين، وكذلك الامر لنفيد البلد باصناف جديده. بقدر اقول لكم انه هالاصناف هيدي رح نلاقي فيها اليوم 15 صنف، 15 مرض، مقاومة ل 15 مرض، يعني شغلة كتير كبيرة. 15 مرض منهم شغلة قليلة. في بعض الأصناف رح تلاقوها مثلا فيها 8 أو 9 أو 7 أمراض فول باكج، يعني disease resistance and disease tolerance. هيدول كمان بدهم شغل كتير، ووصلوا على هالحقل من بعد سنين من التجارب. قبل ما يوصلوا لهون وصلوا بتجارب صغيرة لنتأكد انه مزبوط فعلا هيدول اصناف مقاومة لهالامراض هيدي. فما رح طول عليكم الشرح اكثر من هيك. بدي اتشكركم، بدي اتشكر ارجع مرة تانية الايوبي، بدي اتشكر كل يلي حضروا اليوم معنا، يعني يلي هن شركاء ليونيفرت، المزارعين والمستثمرين بالحقل الزراعي والتجار يلي عم بيشتغلوا معنا. اهلا وسهلا فيكم. بنتامل انه يكون هالنهار مفيد لكم ولنا جميعا. واللي بدي اقول لكم اياه انه من بعد ما نخلص الكلمه اللي بدي احكيها والكلمه اللي بده يحكيها دكتور مختار، رح نشوف فيديو صغير، ما في حكي اكثر من هيك، فيديو ربع ساعه فقط لحتى تشوفوا الاصناف يلي حضرتكم عم تستعملوها وتجربوها وتشتغلوا فيها، وهي شهادة لإلكم. الناس يلي رح يحكوا بالفيديو هن ناس جربوا هالأصناف واشتغلوا فيها وزرعوها. فشكرا لإلكم وأهلا وسهلا فيكم. وبترك الكلمة للدكتور ربيع مختار، عميد كلية الزراعة بالجامعة الأمريكية.
عزيزي خليل، مشكور على الترحيب الحار. اهلا وسهلا فيكم بمزرعه الجامعه الامريكيه. بس بدي اعرف كم واحد من موجودين هون اريك كانت فيها فضل علي لوجوده اليوم بالحقل الزراعي. ما شاء الله، شكرا شكرا. اريك لها فضل على الكل، لها فضل علينا كثير. تاسست من 76 سنه كمركز بحثي، كمركز تربوي، وكمركز تواصل مع المزارعين والقطاع الزراعي. وبعد اليوم وراح تتطور أكثر كمركز مش بس للزراعة، كمركز للمصادر المتجددة. مستر ملكي بترحيبه حكى انه اليوم هو بالاضافه هالتعاون، نحن صار له 25 سنه وان شاء الله بيستمر ل 25 سنه ثاني. في 3 شغلات عم بتصير اليوم. في اليونيفرت فيلد داي، في اريك ريسيرش داي، وفي معنا مجموعه من وفره هي مثل ما كنا بنعرف اباندنس. والفكره من وفره هو انيشيتيف لكل الجامعه الامريكيه لقيام ترابط ما بين الهندسه والزراعه والطب والاستشفاء بكل قطاعات الجامعه الامريكيه، لحتى نشتغل كلنا سوا لايجاد وفره بالتعاون. ان شاء الله انه يكون في فرصه تشوفوا الابحاث اللي المشروع وفره عم بيأمنها، وهي وفره رح تكون خريطه طريق لاعاده انماء القطاع الزراعي، مش بس بالتركيز على البرودكشن اجريكلتشر، بس هي التركيز على الاستمراريه والاستدامه في الزراعه اللي مبنيه على مصادر متجدده للمياه، مبنيه على مصادر متجدده للطاقه، مصادر متجدده للتربه، بالاضافه للريجنريتيف اجريكلتشر. الزراعه الموجوده اليوم بحاجه لتطوير، بحاجه لتكنولوجي، بحاجه لبيج داتا، بحاجه لارتفيشال انتليجنس، وهي هي وفره، وهي الصوره اللي رح خارطه الطريق لاريك. كمان بيسعدني انه بهالمحفل هاي جدد التزام الجامعه الامريكيه والتزام كليه الزراعه بالتواصل مع المزارعين والقطاع الزراعي. هالمركز بلش من 76 سنه كمركز للتواصل مع القطاع الزراعي. كليه الزراعه اليوم عندها وحده، كلكم تعرفوا الاي اس دي يو، اي اس دي يو كانت مركز للتواصل مع المزارعين، لكن اي اس دي اليوم عنده بالاضافه لخدماته اللي قدمها خلال العشر سنين المضوا، اليوم هو وحده متضامنه مع كليه الزراعه لاقامه خريطه طريق بالتواصل مع المزارعين، مع اصحاب القرار، مع الشركات. واليوم كمان بدي جدد انه ب FAFS 2025 الاولويه هي للتواصل مع بين الاكاديميا، الجامعات بلبنان، مش بس مع الجامعه الامريكيه، مع كل جامعات الزراعه بلبنان، تواصل مستمر وتواصل وتنسيق مع القطاع الخاص. بيسعدني اليوم انه اشوف اليونيفرت والاي يو بي والكليه الزراعه بيتواصلوا، وهي ان شاء الله تكون بدايه لشركات ثانيه لانماء القطاع. كلنا بنعرف انه القطاع في مهدد بالخطر لعده اسباب، ورح نشتغل ان شاء الله مع اليونيفرت ومع بقيه الفرقاء لحتى القطاع الزراعي ان شاء الله يستمر بالنمو، ويستمر لاستقطاب كوادر جديده. يعني نحن بحاجه مش بس لناس خلقانين بمزارع وبيعرفوا الزراعه، القطاع الزراعي ليفوتوا على القطاع الزراعي، بحاجه لناس خيارهم الاول الزراعه، خيارهم الاساسي الانماء القطاع الزراعي بلبنان. نحن بحاجه لهالكوادر الجديده، الطاقات الجديده بالمدارس بكل التعدديه الموجوده بلبنان يفوتوا على كليه الزراعه كخيارهم الاول. وبتمنى انه هالرساله توصلكم. في عندنا مساعدات للطلاب تحديدا بكل المحافظات بلبنان لمساعد الطلاب اللي هن قادرين عندهم الامكانيات العلميه العاليه، وممكن بحاجه شوي لمساعده ماديه. اذا عنده حدا اي منكم استفهام بيتواصل معي وبيتواصل مع دكتور حيدر. شكرا كثير واهلا وسهلا فيكم بالمزرعه.
لاقصى حد، اكيد مع متابعه نحن، وهذا الشكل اكثر شكل بيع بالسوق. يعني اي شرحه بتنباع ب 4000 5000 العماني، هاي الشرحه بتنباع دوبل يعني ب 10000 ليره.
وهون كمان بالاضافه لهالاصناف هاي، طبعا انتم بتعرفوا حضرتكم انه هيدي الاصناف موجوده بالسوق ومعظمكم عم يزرعها ويستفيد منها، انما حبينا نذكركم فيها هون، ورح تشوفوها كمان موجوده تحت بالفيل. وكمان بالفيل تحت رح تشوفوا الاصناف الجديده مضويين عليها، حاطين لهم مثل بانكارتات صغيره لحتى تشوفوا انه هيدا صنف جديد رح ينزل سنه 2020. فشوفوه نعملوا معروف، وبنتامل انه يعجبوكم لحتى تجربون وتستفيدوا منهم. بعد في شغله وحده كثير مهمه بدي اتشكر بنوع خاص البروجكت مانجر بارغوستا مستر اندري ابو عبد الله للتحضير والسيتنج الحلو يلي عمله لهالفيلد داي بالذات اليوم، والتاتش تبعيتك يا اندري موجوده وين ما كان. ثانك يو فيري ماتش. اذا بتريدوا هلا فيكم تتوجهوا على الفيلد، رح يكونوا التي سي بيز كلهم موجودين حدكم لحتى تروحوا مجموعات وتشوفوا الاصناف وتسالوا عنها الاسئله اللي بدكم اياها، ومثل ما قلت لكم فيكم تصوروها، فيكم تدقوها، فيكم اللي بدكم اياه، على اساس انه معنا شي ساعه ونص، ومن بعدها الساعه 1 بنتلاقى كلنا سوا هون لحتى نروح سوا على الغداء نتغدى مع بعض. واهلا وسهلا فيكم، تفضلوا.
اهلا وسهلا بالحاج.
اهلا بكم. كيف البيرونيا؟
بيرونيا ممتازه. حبيبي لانه شوف عملها
هي بتطير اكثر من كرسي. ما رايك لايك بس كده بسألك سؤال.
تفضل يا عم.
هلا قصة هيك.
اذا عجبك شيء فينا ناكد الموضوع.
بس ما شفتها كثير يعني ما شفت شفتها ايه بس شفتها هيك
صار من عبكره عم بتحضر ايش بدك جرب ترد علي صار له الي شميس مدري قديش عم بيجرب يرد هو والاسمر دان مش دان معكم كمان؟
لا انا وياهم عم نشتغل على
بس بالهيومن كلكم هيومن يا البروجكت تبعي قديش انت عظيم جباره قديش انت تبعتك حلوين قديش صار وصلوا بعد شهر
It's not the money.
It is the money. I don't want to go broke.
The hell with money. يلا guys.
The goal here is basically comparing two different systems, one regular conventional and the other verticulture. So for iceberg production. This year we tried lettuce, a different crop to last year where they did strawberry. Last year they had some difficulties, so we thought lettuce would be a better choice. The main goal here is basically water recycling. So basically, conserving water. We water the lettuce from above. As you can see, the pipes are connected to the cylinders, and there are emitters, one emitter above each cylinder. Each emitter will supply the cylinder with water. The water goes down, and then it goes back down into, we have a barrel there filled with water, which then goes back up, so the water is constantly being recycled. We also put in fertilizer and
That's it.
What is the area, number of plants,
The area here is
significance of this work?
74 meters square. And
A
there's,
day?
74 meters square, and there's 2,200 lettuce right here. Each cylinder has 74
Seedlings.
lettuce seedlings.
Each
like I said.
pipe.
Each one.
Okay.
Each cylinder. And that's it.
okay, and also, okay, so I'll talk a bit about the advantages of this.
Significance.
First of all, I did mention recycling water. This is a huge thing in our country where water is very limited. So I think that this is crucial, the most crucial factor for the future of Lebanon. I think this is the future of growing crops. Beirut, many people, everyone is living in Beirut now. You want to live there, you can grow these on your roofs. These save so much land. Instead of taking up all this space, we have these simple cylinders. You can also place them horizontally, not necessarily vertically, which could, based on your roof or wherever you want to grow it. Okay? Next up, also weeding. There's no need to weed over here. No weeds have grown at all. And if they do, it's simple plucking out. It's very easy. Unlike on that land over here, if I can show you, there are some weeds growing, although not as much as normal. Okay.
So no cultivation here, no pollution for the environment, recycling the water, conserving the water, no weeding, no herbicides. This is the beauty about it, all right?
Yes.
But the most important part, we are saving water, all right?
Okay.
And this is mainly made for urban agriculture or for in refugees camps, if you like.
All right, Marco. Anyway, any questions? First, go visit the site, compare the vertical versus the conventional. And
خبرنا شوي عن النت.
And the nets. Okay, صح, yeah, you're right. I forgot to mention the nets. So we learned if you want to grow them in cylinders, there is going to be compaction. The lettuce is going to be more sensitive. And to protect it from the heat, since it is a very hot summer, we put 2 nets over here. And we only had to put one there. And you see that the lettuce is growing very well, better than the ones here. The ones in here are very sensitive due to there is root compaction.
because of soil weight,
Because of soil
we
weight.
mixed pitmus with some
Pitmus.
potting mix.
We put a ratio of 4:1 pitmus to potting soil. We put the pitmus with and some perlite as well for water absorption. We put pitmus mainly for the water infiltration and to reduce compaction.
But you see that all the iceberg here is really exposed to heat stress. This is a major problem we faced this year. Unlike the conventional, very successful in the vertical system, it seems the iceberg is not good to be raised in such system. Maybe we need to change the crop next year into strawberries or Italian lettuce or whatever else. But
maybe
iceberg is still not good.
You may try different varieties. Different varieties.
Or maybe reduce the spacing between
No,
each head.
this one's a bit.
Why don't go
It's
inside, look at
approximately
it
the
first,
same.
and then compare it to the
But this one has more
field
lettuce.
one, and then we go, please. Go ahead, guys.
Did you measure how much water
Look
you
at them.
lost?
Yes.
How much?
Lost?
Learning process.
Oh, lost.
Remember, this is
Recycling,
a
you
learning
introduce
project.
evaporation, little bit
Expect
of water. Are you
everything,
able
the
to
good,
measure
the
it?
bad,
Did you
and the
suggest
ugly.
something to
This is
measure it?
agriculture, ya Jama'ah.
Think of it, guys. What about the taste? The taste.
That's a good question. Try it.
We have not tasted them
You
yet.
can try it today.
If you want, you can go taste them.
Pick up some. Jeep. The go Jeep. Bring some. See bolting. بيعمل بيحومن لما يروح يزهر بيحومن ما بيسوي خلص ما انا بنقمص شلفت شلفت كيف ببرد مش بالطول بيقولوا لا بيأس من البرد Let's go guys. هذا organic ما عندنا غير fertilizers here a little bit. But this is iceberg, it's the cluster, looks fine in comparison to vertical agriculture. All right?
So what's the reason?
Heat stress, spacing. Maybe it's not good for the pipe. هذه العادية هذا الايسبرج هذا الفيرتيكال.
This is the hydroponic system. My name is Suhair Rauda. These are my colleagues, Muhammad Baibo and Abbas Khanso. Sheikh Muhammad Baibo. So our main objective here first is to learn and test the hydroponic system for lettuce production. Our second objective is to compare between the hydroponic system and the conventional system. And third, and the most important thing is also to compare between the two systems, the quality and the quantity of the lettuce. As you can see here, we started, before we start, these were full of soil. We removed the soil from here. Then we put nylon sheets. Then we filled the ponds with water, and then we put over it styrofoam, and we dig a hole inside the styrofoam, and we bought lettuce. We bought lettuce. We transplanted. We removed the soil, and you used a cup.
This is how they put it in fact. It was young seedling, very young seedlings in fact. Look at this roots, okay?
The main problem we faced here is the heat stress. We faced about 2-3 days of high temperature that caused يعني
That's unfolding.
yes.
Intense light.
We put an air pump. There's an air pump that is موصولة على هيدا البومب لهيدا البومب. Because first we need aeration, we need fertilizers, and in addition to aeration, we need water circulation. So that's why we put also a water pump.
Because the combination of oxygen and nutrients should always be there. Actually, as you can see, the production was not as we expected, but as Dr. Haider said, the main objective was to gain hands-on experience. And every day you learn is a good day. Like we had, if there is a problem in the future that would occur like this one, so we can solve it.
We also planted in addition to lettuce.
ما بقى عم بيحكوا الشباب عطاهم ما في قطع. يلا هلا. بقى so we faced this problem of heat stress. حبيب قلبي. First, it could be a problem of due to the variety of lettuce we planted, because we didn't get special seeds or any specific variety يعني. Summer crop, they could not be مثلا heat resistant. And also we had another problem of the salt in the water. When we added the fertilizer, the first couple of hours we were checking the EC, and it was 500, 600. It should be below 800, but after 2-3 days it rose to about 1000, which is when they started dying. Well, they were doing pretty good يعني 1-2 weeks before. They were all هيك تقريبا same size as those. فبس هيك.
You know, just to brief you, in hydroponics, there are many systems for raising crops in hydroponics. This is the cheapest way, according to Dr. Imad Saud. When Imad Saud اختفي. So anyway, Imad recommended this system. Since we have those basins here, he said remove the soil, put plastic sheets, put water, add some fertilizer, some aeration, and you are fine. This is how they are doing this in Asia, in the Far East, in fact. The cheapest way to raise lettuce or veggie. We tried this here. It seems the system is not working very well. So next year, we are going to update the system by its way. We have to put like pumps, we put some canals, we put some drainage system to make it more suitable and more marketable. But as I said, really those guys, they invested a lot of time, they worked very hard. Imagine the time invested in making the cups, in making the holes, in putting the waters. They change the water many times because the sheets, you know, have some problem with holes. So it's nice, but again, it should be, you know, evolved with time. But what did you learn from this?
We learned, you learn something new every day. صراحة.
New technology.
New technology, yeah. And it could work. It was working fine.
Again, the
we had this
water.
problem, yeah.
You are saving water. You don't lose your water. And we put styrofoam here just to prevent evaporation, all right? So again, the most important part maybe we learned from this, or students, that maybe light, the white light is reflected from here. So maybe there is a heat stress plus more light reflected from here. High light intensity could, I don't know, could damage lettuce. Plus the EC, maybe black, I don't know exactly. So we are going to try, you know, testing more crops in the future. We have problem with dogs. Dogs, they move here sometimes, you know,
We
wild
lost
dogs.
that trench due to a dog incident.
Maybe we need to put better cups, more holes from the bottom, so you'll have more roots to, you know, to expose. Look at the roots; they are compacted, not loosed. So maybe this is another problem also. Okay, but this is, yani, we are learning from this system, hopefully, yani.
So what do you think is the main advantage of doing the hydraulic thing versus the
Cheap.
cheaper?
Cheap,
No weeding, no cultivation, saving water.
What, especially if the region is limited.
No, I'm not saying this system versus another similar system. I'm saying this versus the regular.
The
What's
system,
the main
because you
advantage?
save water.
First,
Because you save water.
You save water, do you make money?
Should you make money?
At the end of the day.
if you're saving water, هونيك
you can save.
You know, ICARDA is one of 15 international organizations under the CGIAR, which is the Consultative Group for International Agricultural Research. Each center has a specific mandate and mission. ICARDA works on contributing to food security, reducing poverty, and adaptation to climate change, and at the same time, maintain the natural resources and avoid degradation. We are working in, ICARDA started in Lebanon in 1977. Because of the civil war, it moved to Syria and Aleppo. And now, since 2012, because of the war in Syria, we are decentralized and we moved the headquarters to Lebanon, but we are working in different platforms in Morocco, India, Ethiopia, and Tarbal Station in Lebanon. And we have other offices, thematic offices in other countries. So we have the global mission to improve barley, lentil, and faba bean, and a regional mission or mandate to improve wheat and chickpeas. I will talk about 4 main activities. We have research programs in crops improvement, in water and land degradation, in policies, in livestock and forage cropping. But let me talk about crop improvement because this is what ICARDA is mainly doing in Lebanon. We have a gene bank at Tarbal Station. I hope you will have the chance to visit it. We hold around 157,000 accessions of varieties, land races, wild relatives of all the crops that we work with, namely, like I said, wheat, barley, lentil, chickpea, faba bean, and forage legumes. And the idea is to conserve and protect these genetic resources, so we do collection trips and we put in the gene bank. We use these materials from the gene bank for breeding because they have, especially the wild relatives, they have so many desirable characteristics that we work on transferring into our crops that we eat. So the main purpose of the conservation of genetic resources is not only to protect them, but also to use them for breeding and crop improvement. And along that, we have breeding work in Tarbal Station. Along that, we have the seed health testing and to make sure that we don't transfer any diseases because we send genetic material outside the country and we receive also from other countries. So we have seed health testing and field inspection to make sure we don't transfer any diseases outside. The last part, which I want to come to, is what we are doing here at AREC, which is when we have a set of varieties that are promising and doing well, we want to distribute them to our partners in the world. And this is the work we are doing at AREC. We have multiplication, seed multiplication here, and we generate what we call the international nurseries, which are basically experiments that we send to more than 150 partners in more than 50 countries and 2,000 sets approximately that we send every year to partners across the globe, our national partners, in order for them to test this material and select what they find attractive for them. And at the same time, we receive back the data and we see how our varieties are doing in different climates in the world. This is a general idea. Aziz, you'd like to add about the international nurseries itself?
Yeah, but simply as what I said in my introduction there, we produce the nurseries here. About 5,000 accessions we produce seed from, and then the breeders compose the nurseries and send us the list, and we prepare the seed. The seed, we have a small seed processing center there to clean the seeds and treat them. And then we prepare the samples and come here and package them using this machine. Can we start, Ali? I mean, all what we do is that we take a sample and put it in that hopper, and then it goes to the machine and it prepares the number of envelopes that we want, automatically package them, label them, and then get them ready for distribution.
machine is that it do it automatically.
After we package them, based on number of seats, it is the number of seats counted, filled in this packet, sealed and labeled, and ready to be dispatched. Okay, now all the nurseries are ready. Here, you can have a look at them.
Guys, last station, yeah, let's go.
What's going on here?
These are the nurseries packed and ready, waiting for the phytosanitary certificates, certificate of origin, non-commercial invoices, SMTAs to be put in the box and closed, and then we send it to DHL to distribute to different countries in the world. This is the peak of our season. This is the end, almost the end game. By next week, we will start dispatching. Thank you. Yes, please.
Why you didn't work before on chickpeas? Because we said lately we started working on chickpeas.
No, we started working on chickpea since 1978.
But then you stopped?
No, we continued working from ever since. We never stopped.
Good morning, everyone. I am Sarah Slim. I am master's student in environmental engineering from the Faculty of Engineering. My advisor is Dr. Dareen Salam, along with other professors from the mechanical department and environmental department. What we are trying to do here is to implement the renewable energy sources to meet the heat requirements in broilers production. We are using the solar energy along with biogas from anaerobic digestion in order to heat the water. The water, we have 8 localized heating unit inside the poultry house, and the hot water will circulate through the fan coils, assuring the minimum heat requirement at the chicks levels. The chicks, the brooding cycle we started, this is the test number 0, the first experiment, and we are trying to test the system to see if all the parts are working well. We have also the photovoltaic panels. All the pumps and lamps and the requirement in the poultry house are working on the solar, on batteries that are recharging from solar energy. We have 16 PV panels to recharge the batteries, and we have 16 solar panels in order to heat the water in a 1,000 meter cube storage tank. We are doing this project here in AREC in collaboration with other conventional poultry hosts with Razan and Joy. At the end of the project, we are trying to find a way to minimize the cost of production using these renewable energy sources. And we are comparing this system along with the conventional system in the other poultry house, or the conditions in the 2 poultry houses are the same, and we are trying to compare the energy consumption in this house. We are trying also to minimize the environmental impact in the greenhouse gases from the electricity and the manure. The manure in this house, we will use it in the anaerobic digestion. Thank you all.
What is the major problem you are facing here? Tell them.
The major problem we are facing here now is the cooling system. We are trying to find a solution for that. The system is designed for heating purposes, not cooling. So in this hot season, there is a little problems in the cooling. The temperature is rising a bit, but we are fine.
We are surviving.
Yeah.
Okay. Mortality is low in general.
Yeah, the mortality rate is low.
You should also enlighten them that this is also involved in the health sciences regarding the maintaining the health of the people that are going to work. So the system is also involving the idea of the health prospect as well. And this project is really a test for what is known as the WEFRA project.
It's part of the WEFRA project.
That will be launched very soon after the testing ends and everything.
Yeah, this is the first experiment. This is the test of the
It's a
system.
testing thing and it's the testing phase. So most probably when everything is well acknowledged, the project will be launched hopefully with respect to issue.
But it's very important to stress on something that this is a joint project between our students, agriculture, and the faculty of engineering. All right. So they are working together, collecting data together. They are helping Sarah and Sarah helping them, and we are very proud to have Sarah here and Dr. Dareen Salam. You are most welcome.
Are you going to repeat this in the winter?
This is what is known as a greenhouse poultry shed. This is a part of a project that has been approved with WEFRA regarding the development of what is known as a controlled poultry house production, where we control several factors. The objective of the project first is that we use solar panels, so we use renewable energy. We are able to have a reduced geothermal reaction with respect to energy. Second, we can introduce cooling. It's a cooling system by which we use the gases that have been emitted, as well as what is known as an aerobic digester for the production of fertilizers, and the production of fertilizers and gas in order to reduce the amount of energy used by conventional energy systems that are available. Now, this system it's a joint venture between different faculties at the university under what is known as the WEFRA initiative, between the Faculty of Agriculture, the Faculty of Engineering, and the Faculty of Health Sciences, and the Faculty of Environmental Sciences. And this is a testing phase, and hopefully once the testing phase is finished, we're going to launch the project. And usually it will be always in comparison to a conventional system that is regarding to a second poultry house that will be located next to this existing poultry house. Thank you.
Here the aquaculture group. First let me introduce my group. Abed Dughan, Yusuf Saade, and I'm George Rahal. Bridget is the graduate assistant in this project. So this project is under the supervision of Dr. Haidar, Dr. Saoud, and Dr. Abu Jawde. We are working on the effect of fish water on the beans. So this land is divided into several parts. Yusuf will talk about this, how the land is divided. And here we are irrigating with drip irrigation, and some part in well water and sometimes in fish water. So this land is not controlled by any type of insecticide, pesticide, or herbicide. So basically, we are seeing the difference in the plant height, the yield, and the number of insects infestation in the plant.
Okay. Furthermore, we can distinguish 4 patterns because the plots are divided into 4 parts. We have on the right fish water, irrigated with fish water, and on the left irrigated with well water. Also, on the lower part of the plots, we didn't fertilize, and towards the door we fertilized. Since to have well water without fertilization, well water with fertilization, fish water without fertilization, and fish water with fertilization. Our main goal is to see how will the growth of the bean will be affected by the well water or the fish water, and how many insect or how dense is the insect infestation in each plot. Also, we can distinguish that in the pool we have a green color. The importance of algae is that during the day it helps us provide oxygen and it helps provide feed for the fishes. Abed will discuss the advantage of the project.
Okay. So the advantages, first of all, we have conserving water. So at the same time, we're raising fish and we're irrigating our field. Second is empowering women in rural areas. So if they are farming, they have a pond. At the same time, after 6 months, we have here tilapia that live in stagnant water. After 6 months, they sell their tilapia, and at the same time, they are irrigating their field with fish water. Now, how to control the fish here? We have tilapia, around 1,100 fish in this pond. So to control the fish, you should control its environment. That is the water and the feed. And we're testing for ammonia, pH, nitrites, hardness of the water, or alkalinity, and the O2 percentage.
Thank you. Yeah, Jamia, one more thing only, just to stress on something. and this greenhouse, the aquaculture unit, was established last year by students, by AREC students. This pond was constructed by AREC students and Dr. Ahmad Saud. The capacity is 40 cubic meter and can have around like 2,000 tilapia fish. Why tilapia? They will talk more about, not trout and so on. Everything you see here, starting from seedbed preparation, planting beans, irrigation, drip irrigation, everything was established by our students with the help, of course, Nicholas Haddad. Well, Nicholas. Nicholas is really a great helper for the projects, and he is really an asset to the center. So this is under the course of 223, the agriculture projects. Now we are going to move into another project, again, run by Bridget, who is doing master degree here from USA with Ahmad Saud, and also students, AREC, they helped her a lot, and they are still, hopefully they will help her in the near future. Let's move into this other greenhouses. Let's go.
So hi everyone, my name is Bridget and I am working on my thesis research here in these 6 greenhouses. On this side we have a control, and this side we have the trial. We have 3 replicates of each, and the goal of this research is to test the effectiveness of 2 predatory mites on the agricultural pests in the area. So we are working with Swirsky, which is a whitefly and thrips pest, or predator, sorry, and we're also working with Persimilis, which is a spider mite predator. We also are dealing with aphids, which we are spraying with a Bovaria spray when we have that in the trial greenhouses. So in the system we are still using the fish water. As mentioned, we have tilapia fish that are providing fertilizer through their fish effluent, and we are irrigating about 25 minutes per day in these greenhouses. That water reduces the need for any chemical fertilizer addition. We also are not spraying any pesticide in this area. So as we walk through the area, we can start to see that there are differences between the two. This side is very heavily infested with aphids, which means the production and the yield has been much less when we harvest every week. This side we are having a little bit of problems with aphids as well, but we're mostly being able to maintain any kind of pest infestation and keeping it low. We additionally have marigolds that we put in here as an indicator of kind of pests that are coming. So they show thrips and spider mites much earlier than we find them on the crops. Additionally, we have the yellow sticky traps, which I can use to see any increase in infestation. So we have harvested these hot peppers every week for about 4 weeks. This will be week 4. We're still seeing considerable flowering, considerable pepper growth, but it is starting to decrease in the control versus the trial. So we're hoping this will indicate that our project is effective in producing more yield for the same amount of water.
Are you spraying pesticide in your control tank?
No, we are not. We have just let it.
Okay, it's only
control. Only control, yes.
Now, farmers are using a lot of pesticide, and we are concerned about food safety. So this experiment proves for no doubt that natural enemies that are present in the local environment, if we rear them and release them, they are able to control all the pests we have encountered here so far. So they may represent a real alternative to the pesticide used, which are toxic to the humans and to the environment. Thank you.
Thank you.
Hello. Behind us we have 2 strips of land. One is equipped with plastic mulch, the other is equipped with paper mulch. The point of this experiment and its significance is to evaluate the percentage change in moisture content as a function of usage of different mulch material, with all other variables being the same. The mulch height is about 10 centimeters. The plastic height is 0.5 millimeters. شوية رقيق بس مش الحال. We are growing broccoli, and we have not weeded yet so that we can get a good idea of the changes in all cases, but we will do that today. The plot is 3 meters tall, each one, and 80 centimeters wide, which is the same width of the plastic mulch, so they're identical. And the crop is agassiz. It's a summer variety of broccoli, especially suited to the heat. And we have a sensor over there, and the sensor goes in at different points of each mulch. 2 for this paper and 2 for that plastic strip. 1 is over here as a control, where just weeds on their own. And that is how we know moisture content. All of them are put at a depth of 25 centimeters. Any question?
At the same level?
Yes, all of them are at the same level and perpendicular completely to the surface of the soil.
So what are the parameters?
1 hour.
1 hour issue.
What are the parameters you follow?
I put the 20 kilos of paper mulch across each strip. The paper في شي مطحون في شي خشن و the plastic is the same parameters.
Taking data from the data
The sensor, and we compare it to soil samples we take manually to make sure that the work is ماشي الحال.
See the difference between the control and the paper and the plastic, moisture content in each one, so to see which one has more
Which
water.
one saves more water, because the plastic, okay, it might save water, but it's an environmental problem. You cannot get rid of it, and it will only last you for 1 season anyway before it starts to degrade on its own. The paper will eventually degrade into the soil, and actually we're getting close values. So paper long term might just be better than the plastic.
The weeds are an important factor.
Yes, the weeds. Yes.
Yes. Also, the weeds are getting out from the plastic ones. We took them yesterday.
نترك
The paper, no weeds at all.
نترك الويدز شوي، بناخذ ارقامهم، نرجع بنعشب كل شيء، ونرجع بنترك الويدز يطلع ونرجع بنعيدها.
So you have to make sure you are taking account of the weeds and the weed problem and the effect on the yield. Weeds are very noxious. You see.
Yes, but we over here we care more about the leaf analysis.
Anyway, and second thing,
كمان we can measure that.
Okay, بعدين عندك white mulch is very effective هونيك لأن it reduces soil temperature also.
مظبوط.
This is very important, the white mulch.
اي والله.
But what I was really, if you can take the soil temperature.
They do measure temperatures.
They measure
The sensors do measure temperatures as well.
Excellent.
The average value is between 24 and 27 at a depth of 25 centimeters.
For this one it should be cooler, I am sure.
ما هيدي يمكن on the lower end لأنه العالي في 10 سم لفوق يعني.
Anyway.
وكأنه ditch.
But how you are maintaining the paper? When I
put
read
soil
about
on
the project, I thought that
هيطيروا.
wind will blow them up.
ما they are not all uniformly grounded. في شي مطحون، في شي خشن، في شي ناعم. على الخلطة مع شوية تراب جمدوا على بعضهم. And you do not even need water to keep them afloat يعني.
With respect to growth, have you seen difference between the growth here and the growth there?
The plastic mulch initially they grew faster, but the paper mulch don't get heat stressed as much. So long term I'd rather have that. بعدين في weeds أقل هون.
You get better quality probably.
بحس بيطلع لنا better quality here. None of it was given nitrogen, so we can compare يعني. هذيك لراسنا.
This experiment is to study if the plants will absorb antibiotics or not from the soil and the manure and the water. The previous work in the pots, it proved that the plants will take antibiotics. And most work in the world, it's done in pots. Now we are trying to see if the same results will be obtained if we repeated the same thing in the field. Now we have here 3 crops. We have one lettuce, radish, and a cucumber. One leafy, one root, and the other one is a fruit. And we have 2 antibiotics, gentamicin and oxytetracycline. These 2 antibiotics are used by most farmers in Baqa and in the world actually. They add it in the feed as a precaution, and then to prevent diseases, and then it goes in the manure, and from the manure goes to the soil, and eventually it goes in the crops. So this is the first objective, to see how much the plants will absorb antibiotics and if it will go to the edible parts. And also we are sampling from the soil weekly, and to follow up how long the antibiotic is staying in the soil. Day 0 and 7, 14 and so on, to see how long it will stay for these two antibiotics. And the third part will be, we'll take the same samples we are doing if it's how long it stays, and we are going to check on the microorganisms how much resistance is being formed as a result from the addition of the antibiotics. The results will be very important for us, for decision makers, and I think for the scientific community.
Who is collaborating with you?
Collaborating with me, I have this gentleman, say it 2-3 words. This is a student, a master's. Oh, WIFRA. بدك to mention WIFRA, of course. Okay, this is funded by WIFRA project, one of the WIFRA projects at the UB. And actually, this is the first experiment in his master thesis, Imad. And so far, he has been doing a good job. He spent now, this is a month and a half now here, established the place, and Omar also helping him, his roommate, and they are having fun together, working together and learning from each other.
You have nutrition and engineering also.
Oh yeah, with the WIFRA team, it is part of it from the medical medicine, faculty of medicine, faculty of engineering, and faculty of agriculture. And chemistry, also arts and science, we have chemists. And the chemists will be studying how can we clean the water from antibiotics. And so it will be a real complete project. Hopefully the results will be beneficial. Thank you. Okay, thank you. Omar,
so we have 3 treatments here and 3 treatments here, and each treatment has 3 replicates. So we have gentamicin, oxytetracycline, and control for both. These are with manure and these are without manure. So we spread 60 kilogram per 6 meters square, and we put for the oxytetracycline 10 milliliter and for the gentamicin 5 milliliter in each plot. And we do extraction each week for the soil to check.
How did you apply it?
Manure and the antibiotics. We bring very big bags, and we put 20 liters of water with the 10 milliliter of the antibiotic, and we mix them very well, and we put them along the line, equally on the drip line,
along the line.
Yeah. So each week we do extraction to check if the antibiotics is still there, and also we planted 3 different crops: cucumber, which has the fruit, and the lettuce, the leaves, and radish that has the roots, so we can check antibiotics in each part of the edible part of each plant. How we do this? There's a technique called ELISA. We do extraction from the soil and from the plants, and we do it in the lab so we can check if they contain or absorb antibiotics. So yeah, that's the project.
You're sampling weekly?
Each week, yeah. Last week, I started, I took a sample and I extracted the soil from it. Yeah.
The aim of this project is to support scaling up of solutions having WIFRA components. These solutions are developed throughout the course Designing Solutions for Health Challenges and Crisis that is offered under the Humanitarian Engineering Initiative, which is a collaborative initiative between the Faculty of Health Science and the Maroon Sam'an Faculty of Engineering and Architecture at AUB. In the past iterations of the course, food, water, and energy security were repeatedly identified as challenges that affect health and well-being of refugees. Students with solutions having WIFRA components will be provided with seed funds to scale up their prototype and will use the AREC for testing and validating, given its local proximity to informal tented settlements.
My name is Walid Al Khazan. I'm part of the IT team.
A couple of years ago, we put a strategy to partner with the faculty and the various community at AUB to basically help them transform the way how we do things. Originally, we used to say IT is an enabler. We stopped using this term. Now we use the term transform. Why we use this term? Because technology today is a big part of everything we do. And we're trying to take advantage of technology today to basically change how we're doing things and gain that competitive edge. IT is currently part of the WEFRA project, which is an initiative that started by the FAFS. And in particular, for example, we're now currently working on a project for improving waste management. We call it the 3 R's, reduce, recover, and recycle. And we're targeting the restaurants at the Zahle Berdowni River. And we're trying to find ways where we can help them improve the waste management. For example, we're working with them to help providing them means to improve recycling, to work with organization, NGOs to do like food banks. And then hopefully we're trying also to provide compost so that they can use those for the leftovers. So again, IT today is part of everything, and we are we're working on this partnership so that we can help the community, help the research community at AUB and the society around us to gain from this technology to transform things. Thank you.
Hi, I'm Rami. I'm responsible for the research support for WEFRA project and other research projects. Data is everywhere today, especially in the project WEFRA. We're collecting data from sensors, from IoT devices, from the cloud, from Google. We're analyzing a lot of images. All these contribute into a huge data set. This is called big data. To analyze big data, you will need what we call high-performance computing. And this is a service that we provide at AUB, at IT, which is providing high computational power for research projects where the data is too big to analyze. In addition to providing this service, also provide a visualization service to data so that you can analyze the data. And on top of that, we're trying to apply some machine learning, artificial intelligence, so that we can make some predictions on the data itself. On top of all these, we also provide the application support, so building the different automation for different data sourcing, massaging the data, transforming the data, and eventually analyzing, visualizing, and applying artificial intelligence on that. Thank you very much.
WEFRA stands for Water, Energy, Food, Health Nexus Renewable Resources Initiative. It's an initiative across AUB led by the Faculty of Agriculture and Food Sciences. It aims to foster a system of system thinking and to build a community of interdisciplinary researchers. Together, we would like to address the complex challenges of our today's society and also to respond to the United Nations Sustainable Development Goals in its vision of 2030.